Hello everyone, welcome back to another video. I am looking at the introduction to the unit circle. Here, let me write this down. Intro to the unit circle. I forgot to include the title. All right. So guys, I am going to go ahead and get started by defining some terms, okay? So the first thing we need to define is the standard position of an angle. When we're looking at the standard position of an angle, guys, we're looking at an angle that has its vertex at the origin, right here, okay? And one of the rays is on the positive side of the x-axis. That's the positive side of the x-axis, that's one of the rays. And then the other ray, which we refer to right here, guys, all right? And I am just going to go ahead and show this as the angle, and I'm going to use theta to represent it, okay? So essentially, guys, when we talk about these angles, okay, they can be positive angles. And when we talk about a positive angle, we rotate it counterclockwise. However, when you talk about a negative angle, we rotate it clockwise. So if you're looking at this angle that I just drew here, theta, notice I'm rotating it counterclockwise. So this one is going to be a positive measure. So let's say the measure is 120 or something like that, okay? And I'm going to keep using this over and over again. Now, guys, the initial side is the side on the x-axis. Let me use a different color. Initial side of the angle, right there. And then you have the terminal side of the angle, right over here. The terminal side of the angle. So when we talk about angles, guys, once again, you can measure them in positive angle measures or negative angle measures. So if you're looking at a negative angle measure, you might see something like this. So here's your initial side, and then here's your terminal side. So if you're going this way, notice I'm just going clockwise, this would reference a negative angle measure, so maybe negative 45. It doesn't matter what it is, okay? Now, additionally, an angle can be more than 360 degrees. Let me write this down for you guys. An angle can measure more than 360 degrees. Yes, absolutely, guys. How do you get an angle to measure more than 360 degrees? Or in this case, less than negative 360 degrees? Let's look. Well, if I were to start an angle on the x-axis right here, and I go around, remember, the full circle, guys, is 360. So if I were to do a full circle, that's 360. But what if I were to go back around again and maybe end up right here, okay? So I went a full circle, and then I went another half a circle. So a full circle is 360 plus another half a circle of 180, guys. So essentially, I would have an angle that's a measurement of 540 degrees. So this angle right here would be 540 degrees, okay? So yes, and I can do it in reverse too. So I can go full circle around, oops, full circle around, and then continue. So this one would be a negative 540 because I went clockwise. So counterclockwise, positive clockwise, negative, okay? Now, I am going to go ahead and carry on. The next definition I am going to be looking at is coterminal angles. Coterminal, notice it's that terminal in there, referencing the terminal side. So when we talk about coterminal angles, guys, this is another definition. This represents angles in standard position. And when we talk about standard position, remember the vertex is at the origin, and the initial side is the positive of the x-axis, okay? So coterminal angles represent angles in standard position with the same terminal side. So what in the world is this also talking about? Okay, so let's look. So guys, here I am. I'm going to go ahead and go to the XY plane. I am going to use a different color here, and I'm going to sketch out an angle. And this time, it's going to be 120 degrees, okay? Notice I'm going clockwise, so that's a positive 120 degrees. Now, the terminal side is right here. That's the terminal side right there, okay? And so, if I were to sketch out an angle in the opposite direction, as in clockwise, that ends at the terminal side of the first angle. So here, guys, the second angle is sharing the same terminal side with the first angle. So the second angle here would be negative 240 degrees, okay? Now, it's very easy for you to find angles that coterminal. By the way, there are infinitely many coterminal. Yeah, I hope you guys can see that. Coterminal angles. There are infinitely many coterminal angles. So to find them, let me use a different color. To find coterminal angles, guys, it's easy. You simply, okay, add or subtract integer multiples. So multiples. Okay, let me rewrite that because that's running off the screen there. Okay, so you want to add or subtract multiples, integer multiples of 360. So guys, let's look. That angle was 120. So I want to find two coterminal angles with it. I've already found one. I'm going to show you how to find it, by the way. So one coterminal angle would be to add 360 to the 120. So that would give me 480. So 480 would have the same terminal side as 120. Additionally, guys, I can also take the 120 and subtract. Notice I'm subtracting 360, and when I subtract the 360, lo and behold, I end up with negative 240. Now, I could do multiples of 360. I don't just have to add 360. I could do multiples of 360. So one more, guys. So what if I were to take 120, okay, let me use a different color here, 120, and add 2 times 360 to it. You see that? So here, 2 times 360 is 720, and then 720 plus 120 would give me 840 degrees. So again, this is another coterminal angle with the 120 degree angle, guys. And so, essentially, there are infinitely many coterminal angles. All right, that one is very straightforward, guys. So now, the reference angles. Remember, guys, this is an intro to the unit circle. This time around, in this particular lesson, we're not even going to get into the unit circle yet, not quite yet, because we're still defining terms. Reference angle. This is the positive acute. What's an acute angle? Any angle less than 90 degrees, guys. So this is a positive, excuse me, acute angle formed by the terminal side and the x-axis. So guys, once again, I'm going to go back to my angle, my initial angle, okay? So I'm going to use a different color here. Remember, it was 120 degrees. And then counterclockwise, so that's 120 degrees. So if I want to find its reference angle, I would go ahead and find out what is the positive acute angle that is formed by the terminal side and the x-axis. So guys, let's use a different color. Here's the x-axis, here's the terminal side. What is that angle that is formed by it? So if I drop a perpendicular here, okay, that would give me the angle. And so now the question is, what is the measurement of this angle? How do we calculate it? Well, we take 180 and we subtract 120. Remember, you're always going off the x-axis. So if you're going from the positive side of the x-axis to the negative side of the x-axis, you traveled, whether you go clockwise, counterclockwise, you traveled 180 degrees. That's why we're subtracting it from 180 degrees. And so this one will turn out to be 60. So this angle right here, guys, is going to be 60 degrees. Okay? So this angle right here would represent your reference angle. So this is the reference angle, just like that. We're done. Now, there's more to be said about the reference angle. Obviously, there's a reason why we're doing it. So hang on there, guys, okay? We're going to come back to it very shortly. Now, let me go ahead and show you one more, but this time we're going to do it with a negative. So this time around, let's say we have the XY plane here, and then here's the initial side on the x-axis, and then the angle is going to go over here. All right, notice we're going clockwise, so this is going to be a negative angle, and be 150. So I want the reference angle to this negative 150 degree angle. So I'm going to go ahead and drop a perpendicular to the x-axis. All right, so now my job is to figure out this angle. So again, it's going to the x-axis. I'm going to take 180 and subtract 150. So this one is going to be 30. So the reference angle here is going to be 30 degrees, guys. Just like that. We're done. All right. Now, hopefully, you guys are getting this, but of course, if you're not getting it, I can go ahead and clarify some of this in class for you. Now, we are actually going to use the reference angle to find the value of the 6 trig functions, guys. The 6 trig functions for an angle theta. Okay? So this one you will be given a point, and we're going to reference the point as x, y. So first thing we need to do, guys, is to find the reference angle. Actually, you know what? I need to use an example. So here's the point they're giving you, guys. The point is -3, 6, okay? So think about where -3, 6 is located in reference to the xy plane. -3, 6 is going to be somewhere in the second quadrant. So guys, if this represents point P, and remember when we talk about these angles in standard position, we have the vertex at the origin, and so the angle, remember, this is the initial side, so the angle would travel from here to the terminal side, which is where point P is located. So P is on the terminal side. Let me write this one, a point P on the terminal side. I've got to include that, okay? P is on the terminal side, guys. So now, we have point P, that's on the terminal side, and its coordinate is -3, 6. Remember, when you have a coordinate point, it's x, y. Now, guys, we're going to drop the perpendicular right there. Once you drop the perpendicular, now think about this. This point right here is -3, 6. So we are traveling from the origin, -3 units to the left. Now, because we're talking about distance, it has to be a positive value. So I'm going to just change that to the absolute value of -3. And then to get to this point up here, we got to travel vertically how many units? 6 units. Okay? So now, guys, we're going to use this information to help us calculate the radius. And the radius, what does it look like? It looks like the hypotenuse. All right? So, guys, look at that. The hypotenuse. So let's calculate it, guys. So in order to calculate the radius, we're going to use the Pythagorean formula, but we're going to say the radius is going to be equivalent to x squared plus y squared. The square root of x squared plus y squared. I can hear some of you right now asking me, where in the world did you get this formula from? Here's where the formula came from, guys, okay? Remember, when we talk about the standard equation of a circle, it is x squared. By the way, with the center at 0, 0, it's x squared plus y squared equals to r squared. That's the same formula as the Pythagorean theorem, guys. Oh, you can't see it at the bottom there. All right, let me erase this. I'm going to write it down again. So it's x squared plus y squared equals to r squared. So if you want to solve for the radius, what do? We take the square root of both sides. And that's how we calculate the radius. Okay, guys? That's where that formula comes from. So now we're going to go into the formula and plug in what we have. So we have r will equal to, okay, I just got a little issue, guys. I just lost everything. It says, okay, there we go. Hopefully, I can continue recording, okay? So r will equal to the square root of, it says my battery's running low. 3 squared, so I'm going to have to finish up soon. 3 squared plus 6 squared, so we're going to work it out. 3 squared is 9, 6 squared is 36. We add these two together, guys. So what are we going to end up with? We're going to end up with 45. Now, listen, we have to simplify this, guys. Simplify the radical. You cannot just leave it like this. You cannot leave a radical without simplifying it. You don't have to be told to simplify it at this level. If you can simplify it, you must automatically simplify that radical, guys. So 45 is 9 times 5. Take the square root of 9. That gives you 3 radical 5. So guys, the length, the radius is 3 radical 5. So once we find this, we can go about finding our 6 trig functions. Now, at some point I was supposed to be writing steps, but I forgot to write the steps. So let me go ahead and clear out some of this information and I'll write the steps down for you guys so you can see how to go about using this information, which I just discussed with you, to find the 6 trig functions. Okay, so I'm going to erase all of this. I'm leaving the figure here because I'm going to need it. All right, so guys, here are the steps. Step 1, find the reference angle. Find the reference angle. Now, once you find your reference angle, number 2, you're going to, let's see here, find x and y. Actually, you should list them because they already give them to you. Find x and y. Number 3, you want to go ahead and use r equals the square root of x squared plus y squared. Find the radius, which is essentially the hypotenuse. I'm going to use HYP right there. Okay. Now, remember the radius, guys, is a distance. So we're talking about distance within the reference angle here. So you cannot have negative values because we're talking about the triangle. The sides cannot be a negative value. So be careful with that. And then the last step is to go ahead and find the 6 trig functions. All right. So guys, let's quickly run through this. So we're starting off with sine theta. Sine theta is going to be the opposite. Remember the opposite over the hypotenuse. Ooh. Okay, I think I might just leave this one to you guys so you guys can finish it out. 6 over 3 radical 5 because my iPad is about to power down. Okay, so now guys, you want to go ahead and simplify the radicals. By the way, let me just mention this. You gotta simplify, guys. You don't have to be told to do this one. You have to simplify if it's possible. And if you can rationalize the denominators, you also have to rationalize the denominator, such as the case with this problem. So then you would have to multiply both the numerator and denominator by square root of 5. So what would you be left with? 6 radical 5 over 3 times 5, which gives you 6 radical 5 over 15. But guys, this needs to be simplified. So when we simplify this, what does it reduce to? It reduces to 2 radical 5 over 5. So I am going to have to cut this short. I know I didn't do all of them. I feel like I should do some more. You know what? Let me see here. It has my power here on my iPad. Let me go ahead and get through the first 3 at least, guys, okay? So let me go over here and erase some of this. And then I will go ahead and leave the other 3 up to you guys, you know, the inverses. Okay. So here we go, guys. So let me go ahead and quickly do cosine. And remember, cosine of the angle is the adjacent over the hypotenuse. And so for the cosine of the angle, guys, we're going to get 3 over 3 radical 5. Now for this one right here, you know what I'm going to do first? I'm going to simplify it. And then I'm left with 1 here, so I'm going to multiply it by radical 5. Okay, I think this would have been easier on the first one too. So radical 5 times radical 5 gives me 5. So there's the answer for cosine theta. And of course, tangent theta is going to be easy. Why is tangent theta easy? Because it's the opposite over the adjacent side, which is 3. So when you simplify this one, guys, you're going to end up with, 2. And there you go, guys. There's your answers. That's it. Okay. Oops. Shazam. All right. So I think, you know, I'm going to do one more thing and then I'm going to stop here. All right. So here's the last part about this, guys. Okay. Because I mentioned that I was going to do an introduction to the unit circle. All of this is leading to the unit circle, but let me go ahead and just mention the unit circle. Okay. So a unit circle, guys. Notice the unit in there is a circle with a radius of 1 unit. And guys, remember, I just mentioned that the radius is the same thing as the hypotenuse. Okay, so let me see how my drawing skills are so I can go ahead and mention this to you. So I'm going to go ahead and draw a circle, guys. So there's my circle. Okay, now this circle has a radius of 1 unit. All right, now I am going to call this angle right here, the center angle, theta. I'm going to drop a perpendicular to the x-axis right there, guys. So here, the radius is 1. I've got my x-axis, okay, the distance from the origin to this point right here. We're going to reference it as x. And the distance from this point to this point right here, we're going to reference it as y. So looking at the circle and going back to the right triangle trigonometry, okay, remember sine, guys, of the angle is the opposite side, in this case y, over the hypotenuse, which is 1. So this simplifies to theta. I mean, Shazam, not theta. This simplifies to y. Additionally, cosine theta is the adjacent, which is x, over the hypotenuse, which is 1, we will simplify to just x. Hopefully this is making sense as we go along. And of course, tangent theta would be represented as y, the opposite, over x, the adjacent. Now, this is the last point I'm making, and this is a big point right here, guys. So essentially, what just happened, this is what just happened, guys, okay? This means, you know what, let me use the red. Every point in the xy plane is x comma y. So what we just defined was that sine of theta is equivalent to y, and cosine of theta is equivalent to x. So that x comma y, we can rewrite it as cosine theta comma sine theta. And if that is the case for every single point in the xy plane, then this means, guys, that tangent theta is actually sine over cosine. Okay? That's a big point I just made, guys. That's a really big point right there. Hopefully, you guys got it. And I think I'm going to stop here. By the way, one more thing. When we talk about the quadrants, we'll come back to this again. In the first quadrant, both x and y are positive. In the second quadrant, x is negative, y is positive. Okay. In the third quadrant, both x and y are negative. And in the fourth quadrant, you know what? Let me go ahead and use color here so I can separate these. And in the fourth quadrant, guys, remember x is positive and y is negative. Shazam. Okay. So I'm going to leave you guys here until the next video. I will see you guys in class where we can discuss this further. So until next time, guys, bye.